Hi, my name is Sam Miller. Welcome to Chemistry. Today we'll be learning about kinetics, or the study of rates of reactions. I'll be joined by my friends Zach, Renee, and Bailey. So I'll be teaching you how to do a little lab using these guys right here, and your goal today is to learn a little bit about why kinetics works the way it does.
Remember that higher temperature increases the average kinetic energy of a substance. With this higher temperature comes a higher chance of collisions of molecules and a higher chance of meeting the activation energy of a reactant. Today, we will be using the reaction between Alka-Seltzer and water to demonstrate how reaction rates change. We have 2 glasses of water. One is hot and one is cold. When we drop the Alka-Seltzer in the different temperatures, there is a notable difference in reaction rate.
Thanks, Bailey. Surface area is fairly self-explanatory. When more surface area is exposed to a reactant, the reaction rate will increase. Consider the same reaction between Alka-Seltzer and water. This time, both the water temperatures are the same, but one Alka-Seltzer is in powder form. Notice how fast the powdered Alka-Seltzer reacts. Finally, we'll be talking about how concentration of reactants affects the reaction rate.
With an increased concentration of reactants comes a higher rate of reaction. This is because higher concentrations mean more opportunities for molecules of reactants to collide. Check out this reaction between aluminum foil and 2 different dilutions of sulfuric acid. Each of these acids has a different hydrogen ion concentration, and when the foil is put into each of them, they react at different speeds according to these concentrations.
Thanks, guys. So today you'll be exploring all of these same concepts, but we'll be making atoms and molecules a lot bigger so you can see how they interact. Now, to get started, there are 4 different programs you'll need to run on 4 different devices connected to 4 different spheros. The programs all have the same name, but are numbered 1 through 4 to make them easy to find. Connect your spheros to each device, and when you start the program, make sure to start all 4 spheros at the same time. When looking at the code itself, you will see 3 large code blocks. Each of these code blocks will start a different program talking about each of the different concepts which we covered today.
First up is temperature. The code block for temperature should already be connected to the OnStart program block. It looks like this. When you activate the code, the spheros will move quick and be red. This is to represent a higher temperature. After some time, the spheros will turn blue and move slower. This is to represent a lower temperature. Make note of how many collisions happen in each phase and how hard the spheros hit each other.
The next section concerns concentration of the molecules. Swap out the code for temperature and insert the one for concentration. The code block for concentration looks like this. For this section, the spheros will move at a constant speed, but 2 of them will leave the group after a period of time. Yet again, note the number of collisions happening between the spheros.
The final section will demonstrate surface area of the reactants. Swap out the code hooked to the OnStart program block for the surface area code. The code block for surface area looks like this. In this portion, the spheros will start off vibrating in one small group. Think of this small group as a chunk of a reactant and think of the size of the box as all the other reactants around it. At some time, the spheros will split off in their own directions. This can be thought of as a powdered reactant. Make note of how many times the spheros collide with the sides of the box for each case.
Alright, so today you've learned that chemical reaction rates can occur at many different rates according to the reactant's temperature, exposed surface area, and concentration. And we've taught you today how to demonstrate these concepts using Sphero robots. We hope you enjoyed our little lab tutorial today, and we thank you for stopping by.